Hi, my name is Dominic Merazidov. I'm a marine researcher, and I am discussing whether a more compact design using 90-degree elbows produces unacceptable noise compared to that of the gradual bend in the PICO 40L bubble chamber cooling system. PICO is a collaboration experiment located at the Snow Labs in Canada, and they are determined to detect dark matter using a bubble chamber. Bubble chambers, how they work is that when a particle enters the bubble chamber, they collide with the nucleus, producing tons of energy that is lost through an explosive phase transition. This phase transition creates a bubble from the liquid to the gas state. This state of gas in the bubble can be visually seen and audibly heard. It can be visually seen by a camera, audibly heard by transducers. You can also think of them as microphones surrounding the system so that they can pin locate all these bubbles. Now, bubbles made by radioactive background are much louder than that of what is theorized for the WIMP particle. WIMPs are a certain type of particle for dark matter that has been theorized trying to redefine the standard model particle physics. Now, because WIMPs are so quiet, they need to be the systems need to be really sensitive so that they can distinguish between the two. They don't want any other sound in the background clouding it. Before PICO upgrades from the 40-liter bubble chamber to the 250-liter bubble chamber, they have much need to increase the fluid flow within the chiller system that keeps everything cool, as well as they want to make the chiller system much more compact and easier to manufacture. Now, this cooling system that is right now is using a gradual bend. These gradual bends take a pipe or a tube and they gradually bend it over a curve. If they were to use an elbow, that takes a copper tube, connects an elbow such that it is a straight 90-degree inside. Now, they don't want to make this system more compact with the loss of increasing sound and ruining the test. So they have asked me to assess whether a more compact design using 90-degree elbows produces more sound than that of the gradual bend. To test this, I created two different segments. One is of the copper tubes connecting to an elbow, and the other of copper tubes that is gradually bent at 90 degrees. These segments can be interchangeable between two garden hoses. One garden hose is connected to a faucet in which I can control the flow rate throughout the system to keep everything controlled, and then the next hose is draining into a sink. Because everything is controlled, I am able to test the before and after effects using transducers for both systems and compare them. I use these transducers, you can also think of them as microphones again, to record the sound between the right before the elbow and the bends, and then right afterwards. What I was able to find was that overall, the bend created more noise than that of the elbow, contradicted to my hypothesis that the elbow, because it increases the turbulence, would be louder. But what I also saw was that the sound before the elbow is louder than that of the sound after the elbow, leading me to consider that the sound is being reflected within the elbow. If you think about it, because the elbow is a straight 90-degree angle, when the sound is entering and it hits that wall, it's being reflected back almost as if a light beam is being reflected on a mirror. But because it's not being pushed that side, unlike a gradual bend that keeps it going forward, the sound does not actually make it to the latter part of the system. I have recommended to PICO that they use a more compact design, not only because that the elbow is quieter than that of the bend, but also because the elbow acts as a decoupler, decoupling the sound from the chiller system to the actual test, making the system and the test more compatible with each other, even though they're going from a more gradual design all the way down to a more compact design. Thank you.